Hello everyone, in this video I am going to describe the application of loads, loading displacement, support movements and temperature stresses. So for that, here is the data given, that is a fixed beam having a length of 5 meter. So for that, click on new in STAAD and then fill the file name and click on create. Here the window will appear. Then for creating beam, click on the geometry and grid, beam grid, and change its view from the view option, that is to front view. Now draw the beam of 5 meter length. Here's the beam of 5 meter length is created. Now assign properties to this beam. For that, click on properties, define option and choose its section. I choose rectangular section having the dimensions 0.3 meters by 0.3 meters. Click on add and close. Now assign this dimension to the beam by clicking on assign to view. The section get assigned to the beam. Now move to the supports, create option. I choose a fixed support, click on add. Use cursor to assigning the supports. Now after assigning supports to the beam, now for applying loads on this beam, click on loading, load case detail and add. Choose the loading type as dead and rename its title. Add and close. Now inside the dead load, again add and choose the temperature loads. Put the value of temperature change for axial elongation as 10 degrees Celsius. Add and close. The load is created but didn't assign to the beam, as it is visible from the red question mark appears. So for assigning, click on the temperature and assign to view. As the blue arrows are visible, these arrows represent that the temperature stresses has been placed. Now for analysis portion, click on analysis, define commands, add and close. After analysis, click on run analysis to find out the errors. Now go for post-processing mode to find out the responses, that is deflection, displacement and reactions. Here's the reaction force or resisting force is 195.66 kN at support A and minus 195.466 kN at support B. We can also determine these resisting forces manually by putting formula. Here's the beam whose length is 5 meter and supports are fixed, and then after taking the values of modulus of elasticity and coefficient of thermal expansion from the command file in the STAAD Pro and put these values into the formula, that is stress is equals to alpha delta T into modulus of elasticity, and multiplying the stress into the area of the cross section will get the resisting forces, which is our reaction force, that is 195.46 kN. Now for support moments, click on add Inside nodal load, choose the support displacement option and put the value of displacement in meters. Now for assigning, click and use cursor to assign option. Here's the equal to sign represent that the displacement to the support has applied. Now for analysis, click on analysis, define command, add and close. Now run analysis. Go for post-processing mode. The displacement and other responses are shown here. Reactions, beam results, that is bending in Z direction, shear in X direction, bending moment in and moment in Z direction.